Hi, this is Henning from Product Management TwinCAT again. In this video, I will give you a short overview of the C++ integration into TwinCAT. Let's start with the Visual Studio. I have now opened Visual Studio 2022 here in this case, where we previously have installed TwinCAT already. So we are able to open a new project or create a new project as usual. And that will then simply be the foundation for our C++ module we are going to have in the next minutes. So we are adding a C++ module. Either we have a version C++ project or a static library. The normal case is that we are starting with a C++ project which is versioned. We have different templates here which could be added by default. I start with a cyclic I/O, which means we have an I/O, an input and output data area, as well as this gets cyclically called afterwards. And we provide a name here. And basically that was it already. We have generated all the different code files we have within the C++ project here. But in contrast to the PLC, we need to manually add an instance of this cyclic I/O module we have chosen at the wizard to be generated. So we are adding a module here, which gets here, and then we need a task, which is actually later on triggering this module. So we are adding a task. And we are assigning in the context the task to the module. So what will TwinCAT do later on in the runtime system? The task, which is configured to be executed each 10 milliseconds by default, will call the C++ module. What actually does that mean? Calling a module. Calling a module means that we are about to get triggered by the cyclic update method. So this is actually the code which then gets triggered by the task 2 in this case for being executed on a cyclic base. Of course, we have inputs and outputs, so we are able to access the input values and provide or write the output values, which then could be mapped to the I/O system or to other C++ or PLC modules. And this code is the one we are about to execute or we are about to replace. Before that code and after that code, there is a state machine, which is described in the information system in detail, which is about to start the module as well as stop the module. In this case, so the cyclic I/O template we have chosen to be generated, there is a counter member variable, which is incremented by the input dot value. And this counter value actually is written then to the value in the outputs. So this is the behavior we'll have. Before we could start and debug, I would like to point out that we have the different project settings here, as well as settings regarding the resources for the target system and the file system export here. And on the C++ node, we have the C++ debugger, which needs to be enabled because this is a special port and we only want to have that in development environment. If we now choose to start also with the debug compile flag, we are more or less ready to go. We are simply say right click and build the complete system. That was it for this short overview. We are heading next to the first run, let's say. So in another video, we will put this module to the run state locally on this machine. So on this computer, for having something like a simulated PLC or C++ runtime system then as a follow-up video. Thank you.